Respected lecturer Ms. Fatin Nabila and greeting to all audience. Today we are going to present our project final report with the title Malaysia Airline Flight Booking and Management System in the course code of BITP 1323 database. This is our team members. Our group leaders is Neo Chen Yu and the team members is Chong Jia Sin and me, Li Yon. Next, I will talk briefly about the introduction. The airline industry in Malaysia is growing rapidly due to the increasing domestic air travel, creating a need for an efficient flight booking and management system. A centralized system helps airlines manage flights, bookings, passenger data, staff, and payment more accurately and efficiently. By improving data organization and reducing errors, the system enhances customer service and support better operational decision-making in the Malaysian aviation industry. There are three objectives in our project. First is develop a centralized database for flight, passenger booking and payment. Secondly is streamline flight searching, ticket booking and booking management. Third is generate accurate report to support airline decision making. Next is our entity relationship diagram ERD. There are 6 entity tables and 2 bridges. The entity table is staff, passenger booking, payment, special request and flight. And the bridges is passenger booking and flight staff. These all tables is connect to each other to present this project. Next, I want to state the business rules used in our project. First is one passenger can make one or many booking, and each booking is made by only one or many passenger. This calls a bridge entity which named passenger booking. And secondly is each booking will generate only one payment, and one payment is generated for exactly one booking. Third is one booking can request 0 or 1 special request. Each special request is only requested by one booking. And fourth is each flight is booked by one or many booking, and one booking is booked for only one flight. Fifth is only one staff is assigning to one or many flight, and each flight is assigning to one or many flight. This calls another bridge entity in this case, which called the flight staff. Next is data definition language DDL. We use some DDL in our project to create 6 tables and 2 bridges. We use the data type of varchar and number. First is table passenger. Primary key is passenger ID. Table staff. Primary key is staff ID. Table flight. Primary key is flight number. Table booking. Primary key is booking number with the foreign key flight number. Next, this is a bridge entity where the primary key and the foreign key is the same, where is the passenger ID and booking number, and the description is nullable. Next is table payment. The primary key is payment ID and the foreign key is booking number. Next is the staff flight. This is also a bridge entity where the primary key and the foreign key is the same, staff ID and flight number. And also the description is nullable. The last table is special request table where the primary key is request ID and the foreign key is booking number.
Next, we're going to look at our data manipulation language, which is the DML. We have 3 parts in our DML. The first part is data insertion. So first, we will look at the passenger table. We have inserted all 9 values in our table. For example, like passenger ID, gender, age, first name, last name, home address, and also phone number. So for all the remaining tables, we use the same concept to insert our data. This is for the flight table, booking table, passenger booking table, payment table, staff table, staff flight table, and also special request table. Next, we'll look at the second part, which is data deleting. First, we will look at the passenger table. We deleted the row for passenger with ID P009 in the passenger table. The table shown here is the table that we already deleted the data, so we were left remaining of 8 data. So next, we will look at the flight table. We deleted the row for flight with ID F1009 in the flight table. Same as the previous table, the table here shown is left with 8 data, so means that the data with ID F1009 is already deleted. Next, we will look at the staff table. We deleted the row for staff ID S009 in our table. So here we will see there is still remaining of 8 data. So now we will look at the last part of our DML, which is data updating. So we changed the age of Aisha from 22 to 23. From the table above, we can see that the initial age of Aisha is 22, and after we inserted our SQL statement, the Aisha age is changed to 23. Next, we will look at our payment table. We changed the payment date of passenger ID with PY007 from 11 May 2024 to 12 May 2024. So again, from the above table, we can see that the data is not changed yet. After inserting our SQL statement, the data already changed from 11 May until 12 May 2024. So last is our staff table. we change the phone number of Ahmad to the latest phone number. So you can see from the upper table, this is the previous phone number for Ahmad, and after updating, so now we can see that this is the updated phone number for Ahmad.
Now we continue with the structured query language SQL. The first topic is selection and projection. The first query is to retrieve the names and telephone number of all staff working for the airline. So we need to select staff first name, last name, and phone number. This query only involves staff table, so we write from staff, and this is the result for the table. The second query is to retrieve the payment details for booking number B001. So we need to select payment details include payment ID, payment method, total amount, and payment date. And this query only involves payment table, so we write pay from payment. Then this query have this specific booking number, so we write where booking number equal B001. So this is the result of the table. The third query is to retrieve the flight details that depart from Kuala Lumpur. So we need to use the select all. This is the symbol, and this query only involves flight table, so we write from flight, and this query have give the specific departure location, so we write where departure location equal Kuala Lumpur. Then we can use order by to arrange flight number in ascending order. This is the result for the table. The last query is to display booking map from 1st of May to 5th of May 2024. Then so we select the booking number, flight number, booking status in booking table. Then we only use a booking table, so we write from booking. And this query have give the specific date range, so we write where booking date is between this range. So this is the result for the table. The second topic is aggregation and grouping. The first query is to retrieve the total payment amount collected by the flight system. So we use the aggregation function, which is sum, to calculate the total amount and create a new name, which is total payment RM. And this query only involves payment table, so we write from payment. So this is the result for the table. The second query is to retrieve the total number of booking made for each flight. So we need to only select flight number, booking number, and we use the count, which is aggregation function, to calculate the booking number and create a new name, which is total number of booking. And this query only involves booking table, so we write from booking. And we use the group by flight number, and we use the order by to arrange the count booking number in ascending order. So this is the result for the table. The last query is to retrieve the total number of flights handled by each staff member that has more than one flight. So we need to select the staff ID and the flight number. And we use the count, which is aggregation function, to calculate the flight number and create a new name, which is total number of flight. And this query only involves start flight table, so we write from start flight table, and we use the group by start ID, and we use the having because the query has mentioned if staff member that has more than one flight. So we need to use the having and then count flight number larger than 1. So this is the result for the table. The last topic is join. We go to the inner join first. The first query is to deploy the booking and special request detail for booking with a special mail request by joining the booking and special request table using the booking number. So we write select booking and special request details, and we use the join to join both table and use on the common key for the both table, which is booking number, and we write the way request type equals special mail, which had given in the query. Then this is the result for the table. The second query is to retrieve the flight number and start ID for all staff members assigned to the flight with flight number with F1001. So we select the flight number and start ID, and now we can use the natural join to join flight table and start flight table. Natural join, we do use the common key, then we skip to the where flight number equal to F1001 because the query have given the specific condition. So this is the result for the table. The last query is outer join. So the last query is retrieve the flight details from the flight table together with the booking detail for the booking table. All flights are displayed, including those without any booking, by using a left outer join based on the flight number. So we select the flight details and the booking details, and we use the left outer join to join flight table and booking table, and using the common key, which is flight number. So this is the result of the table. For the conclusion, the Malaysia Airline flight booking and management system was delivered to solve issues such as booking errors, data redundancy, and inefficient manual processor. A centralized database ensures accurate data, real-time update, and smoother airline operations. This project successfully applies database concepts including data modeling, ERD design, business rules, and SQL implementation. The system supports key airline functions such as flight booking, payment processing, staff assignment, and report generation. So this is the end of the video. Bye bye.